Okay, so good morning, students. Today I am going to demonstrate to you on how to add vectors using the Polygon method. So on your screen, you can see that there are three vectors. We have named it as vector A, B, and C. Now, vector A is 5 kilometers east. Vector B is 3 kilometers 50 degrees south of west. And vector C is 4 kilometers 30 degrees south of east. Now, since the unit is in kilometers, we can also say that this vector is a displacement vector. Now, for my scale, I will be using 2 centimeters equals 1 kilometer. I will repeat, my scale is 2 centimeters is equal to 1 kilometer. So let's illustrate these vectors. Now, I have prepared a graphing paper. So you can see there that we have here the north, south, east, and then west. Okay, and of course we have 0 as our point of origin. Now let's illustrate vector A, which is 5 kilometers east. So you get your ruler using your scale, which is 2 cm is equal to 1 kilometer. So from east, I locate my origin, which is at 0. So 5 kilometers in every 2 centimeters. So this is 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers, and then 5 kilometers. Then you put there your arrowhead. You just simply have to double the line to emphasize vector A. So here, in every 2 centimeters, that's equivalent to 1 kilometer. So I will label this one as vector A. Next, let's illustrate vector B, which is 3 kilometers 50 degrees south of west. So what you are going to do is, you are going to get your protractor and put a little Cartesian plane at where you ended vector A. In the polygon method, for you to add the vectors, we use the tail and head method. Okay, so vector B now will be connected to the head of vector A. Now I put a little Cartesian plane so that we can measure 50 degrees south of west. So 50 degrees south of west. Let me mark first 50 degrees south of west. So this is 50 degrees. At this point, that's 50. This is 50 degrees. Okay. Now it is 3 kilometers. So 50, 3 kilometers. So here is my mark. That's 50 degrees. Starting from the tip of the arrow or the tip of vector A. So I have 3 kilometers. Still using the same scale. So I have here 1 kilometer, 2, and then 3. Oh, sakto. So that's 1, 2, and 3. So this is now vector B. Next, let's locate vector C. It's 4 kilometers, 30 degrees south of east. Again, we will locate vector C, or we will connect vector C to the head of vector B. I will again illustrate a small Cartesian plane. So here, we have here 30 degrees south of east. So where is south of east? So 30 degrees south of east. 30 degrees south of east, so here. And then get your ruler, 4 kilometers. Again, using the same scale. So we have 4 kilometers. So I have here 1 kilometer, 2 kilometers, 3 kilometers, and then 4 kilometers. Then put the arrowhead. I can now label this one as vector C. Here. So let's compare. Vector A, 5 kilometers east. Vector B, 3 kilometers, 50 degrees south of west. So this is 50 degrees, 3 kilometers south of west. And C, 4 kilometers, 30 degrees south of east. So this is south of east. Now, how do we get now the resultant vector? I will be using a red pen for the resultant. To get the resultant vector, you are going to connect the starting point to the end point of the vector. So you just draw a very straight line. So we have from point of origin to the last vector. Then you illustrate another arrow. So the red line now is our resultant vector. Okay, now let's get the magnitude. So we said a while ago that in every 2 cm, that's 1 kilometer. So let's get the magnitude of our resultant vector. So the magnitude, 2 centimeter, that's 1 kilometer. Another 2 centimeter, another kilometer. 3, 4, 5, 6, 7, 8. Exactly 8. Okay, so our resultant has a magnitude of, let me write it here, R is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 kilometers. Next, let's get the direction of our resultant vector. Okay, so again, we use the east and west line as our reference. Since our resultant vectors falls under the east direction, so we have to measure using the east as our reference point. Okay, so let's measure. So that is 10, 20, 30. There's a little discrepancy. So we have here around 34. Okay, so that's 34 degrees. Okay, 34 degrees. What's the direction? South of east. So we write here south of east. So this is our resultant vector for A, B, and C using the polygon method.